Hello once again, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek into my personal experiences. This is a channel designed with you in mind. Let us dive into today's lesson. In this lesson, we are continuing looking at not the functional groups. We did this in the previous lessons, where we're looking at the 9 functional groups, and then we said we've got hydrocarbons. There are 3 here, and then which is alkanes, alkenes, and alkynes. So it's already 3, and then number 4 is haloalkanes, number 5 is alcohols, number 6 is aldehydes, number 7 it's ketones, number 8 carboxylic acid, number 9 is esters. That's why we say 9 functional groups, and you look at the definition of a functional group as well as that of a homological series. Now in this lesson we are going to quickly look at the naming of these functional groups as well as the homological series. Now look at this. When I talk about alcohols, how do we name alcohols? Alcohols, we are moving from alkanes. Remember alkanes, for example, we have got methane, right? That is alkanes. That is the alkane part as the foundation. Now when you go to alcohols, what you are changing, instead of the A and E, you are now putting the OLS, the alcohol. Let me remove the S here. The alcohol from alkane, which is the A and E, to the OL. So methane becomes methanol. Okay, so now if you start to name them like that, you can now get the name to say, what do we have? We have number 1, methanol. Number 2 is ethanol. Number 3 is propanol. And number 4 is butanol. Number 5 is pentanol. Number 6 is hexanol. And then number 7, it becomes heptanol. Number 8 is octanol. They say limit yourself to 8, but there would be number 9, nonanol. Number 10 is decanol, and so on. But look at this. I'm just not going to draw now the structural formula of all of them, because we have practiced with number 1 to 3. That's why we did that. But now when it comes to, for example, let me choose one at random. Which one will you choose? Let's choose hexanol. If you're drawing hexanol as the structural formula, this is the naming. Now let's look at the structural formula of hexanol as an example. Everything follows. Now with hexanol, it's 6, 1, 2, 3, 4, 5, 6. Then you have got your hydrogens here. Then the last part is your OH. I think that. So that's how you draw that kind of hexanol. So for now, I will limit this, as I told you that there are 3 types of alcohols. In the alcohol part here, if I can come back to this alcohol here, there are 3 types of alcohols. You have what is called a primary alcohol, which we are going to discuss in another lesson, and then we have a secondary alcohol, and then lastly you have a tertiary, or a 3rd degree, a tertiary alcohol. It's a lesson for another time, not here, but just appreciate that there are 3 types of alcohols. Here I'm looking at a primary alcohol. So this is a primary alcohol. Are you with me? Now that is a primary alcohol. What is it called? It is called hexanol, because the OH is at the end. That is a primary alcohol. So just appreciate that. But the key thing there, from alkane you come to the alcohol, you are adding A and E to OL. That's the alcohol. So you will know all the 8 of them, so you need to be able to draw their structure. Now, okay, before that, also the molecular formula for alcohol. How do you do it? For this one, it will be C. For this hexanol, C6. This is 6, and then H. That's what now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which is H13, and then you've got OH. Are you with me? So that's how you write a molecular formula for that. And then O, you can actually do this to say H14O. Actually, this is much better, H14O, but you need to be able to pick up that this was an alcohol. And then the condensed structure, you will have CH3, CH2. There are how many? 1, 2, 3, 4, 5. You can CH2, and then you can say 5 and OH. Or you can leave out this one here so that you can have CH4, and then you've got CH2OH. You see that? You can have that as the better one at the end. That is the condensed structure RAL formula. On the formula, general formula, let me leave that one for now. On the general formula, but I think, if I'm not mistaken, it's similar. It's C2H2N. I think it's 2N plus 1 and then O. I think that is the general formula for this alcohol. Now let's try, for example, to see for 6. This was carbon number 6. Let's see here if it will match. I mean CN, not C2. It's CN here. Let's see with 6 carbon. It's C6 H2, 6 plus 1 and then O, which is C6 H. Now 6 times 2, 12. 12 plus 1 is 13, so it must be 2 here, actually 2NO. So if I say 2 here, 6 plus 12, then it's 14O. So which means it's CnH2n plus 2O. That is the general formula for that. But if ever there is an error, just correct that. And then we'll move on to the next one. The next one is haloalkanes. Now the other name for haloalkanes is alkyl halides. Now these ones I told you that they end up with C and X. This is the functional group, C and X. And then their naming, guys, it depends. There are 3 types of, there are 4 different X's here. The halides, you have got the fluorine, you have got the chlorine, you have got the bromide, and then you've got the iodine. So it depends how. So this becomes fluoro, this becomes chloro before the name, this becomes bromo, and this becomes iodo. Are you with me? So if we're looking at number 1 to number 2, just look at this. We have got an alkane, 2, and haloalkane. This is haloalkane. So now, what are you changing? You are just changing the name before. From alkane, for example, I'll have methane. If it's a haloalkane, it will be, for example, if it has got F, it will be fluoromethane. See that? And if I'm sketching it, methane will be like this. It will be C. This is methane, the first one. And then fluoromethane will be F, like that. You understand? The F part makes it fluoromethane. If I put a BR, it will be bromomethane, and so on and so on. So these are just open, guys. It depends, but it's just methane. It's alkane, and then the name with an alkane, haloalkane. So you are putting in here the halo, and the halo is these 4. So it's the chloroalkane. whatever alkane. That's all that you're doing. You're just putting the name before. Are you with me? So I'm not going to say much on that one. Let's move on to the next one. The next one is carboxylic acids. And on the carboxylic acids, we said what you have when you move from carboxylic acid, you have got an alkane, and then you're moving to a carboxylic acid. Now look at this. With the alkane, the A and E of the alkane is now changed by oic acid. Oic. So for example, you have got methane. So what will you have here is methanoic acid. Now look at the change there. A-N-E-I-O-I-C, oic acid. You see what you are adding there? And then now it grows from here, methanoic acid, and then you continue now to say ethanoic acid, right? And then propanoic acid, and then you have got butanoic acid from butane, butanoic acid, and then you have got pentanoic acid. Apologies for my terrible handwriting at times. And then you have got a hexanoic acid, and then you have got heptanoic acid, and then you have got what? Octanoic acid. Octanoic acid. Now you can ask me to draw, for example, let me draw number 7 here. Let's draw the structure of heptanoic. My handwriting is terrible, but I believe yours is even more terrible. Heptanoic acid. By the way, guys, I'm left-handed, so the handwriting can be a problem at times. 1, 2, 3, 4, 5, 6, 7. Remember, it's 7 for heptanoic acid. Now, I just want to show you this. You are allowed also to do this. Start from here. My hydrogens, it's allowed. It's not like you have to everything must be from left to right. The functional group is still allowed to have the functional group. At the beginning, it's still heptanoic acid. Now, look at this now. When you're in the last, remember the functional group? Let me recap on the functional group of a carboxylic acid. Remember, it's COOH. This is the functional group. So I wanted to put it there, but I can put it at the end here to say double bond OH. It can come at the end like that. It's still fine. You know, that is still the same. If I can just do this, because you might feel a little bit uncomfortable to say, but I don't feel comfortable when it's like that. Guys, it's the same thing. It's like you are taking this. Let me show you. I hope this will allow me. It's like you're taking this one. It's like you're taking I didn't want it with the thing. Yes, there. It's like you're taking this out. No, but it's fine. Let me bring it back. It's like I'm taking, let me try again, this. Anyways, coming out together. I'm taking this out, and then I'm coming here, and I'm putting this one here. But you see, now I need to rotate it. Sorry about that, but that is almost like what I'm doing, just that when you're rotating is something else. You see, then I put this here to say it is like this. I think just at the C now, I need to control the C so that the C can be like this. That's the same. Even if it's down, it's still fine, but if I put it up like this, It's the same thing. And then I take this guy here, I bring him also in the end here. But what I'll do, I'll also further take this guy out of the way, put him here at the end, take this guy here at the, I hope you see what I'm doing. It's okay, we can actually even remove this guy. It's like I did this here. Take this guy closer and take this guy closer, and this is in the wrong place, you put it in the right place there. It's the same thing, nothing has just changed, nothing was lost. You saw I was just interchanging. Even if it's at the end, it can be on the end here, it can be on the other side. All right, what is this? This is heptanoic acid. So if I say condensed structure, it's CH3 CH2. How many CH2 do we have? It's 1 2 3 4 5. So it's 5, and then you've got COOH, condensed structure. All right, so that was that part. And let's leave on the general formula, but that is that molecular formula. This is the molecular formula. When you're doing the molecular formula, you're going to say it's C8H 1 2 3 4 5 6 7 8 9 10 11 12 13 14 H14O2. This is the simple molecular formula for that. Now the next one is an aldehyde. Now when you are moving from an alkane and then you're moving to an aldehyde, right? So when you're moving from that, so with the aldehyde, where you've got the alkane, now the unique part with the aldehyde is the E per se, and then we are adding the Al. So for example, I have got here methane, so it's methane, I want that E out, and then I've got methanol. Look at this one. So I've got ALE instead of what? Instead of E, methane, and then it's methanol. Now you can continue with the naming of these from methanol. You have got ethanol, you have got propanol, This will continue until octanol, guys. You cannot be just repeating this, octanol. Alright, once you master the first ones, you'll be able to do that. So now let me say I choose number 4. Number 4 is the structure. Let's draw the structure of butanol. Let's draw the structure of butanol. Now butanol, remember the functional group of an aldehyde, it's C. I told you this one, very sensitive, O, and then you've got H like this, and we are writing it as condensed. It's CHO, very important like that. So butanol, it's 1 2 3 4. Then you've got that, then you have that, that's the end, and then in between you put the hydrogens. Okay, and then as I said, it's allowed to even start with this group here to say COH C1 3 4. So you are allowed to do this. Alright, it's very allowed. You can start with the functional group. It's still the same thing. You will see when you come to naming of these compounds. Alright, now when we have done that one, we move on to ketones, and I think these are the last ones. Actually, yes, it's ketones, because esters, we're going to name them later. Ketones. Again, we are moving from what? We are moving from alkanes and then you are going to ketones. Let's say alkane to ketone. Now the ANE of the alkane is the ONE of ketones. For example, now with the ketones, be very sensitive now. The first ketone has got 3 carbons. You cannot start with 4 carbons. So it starts from this one. We have got an alkane, which is propanol. For example, this one is propane. So if you are adding one, it would be propa, and then ANE becomes propa. This is propane. Let me see, it's actually alkane, and then you are adding ONE. You are adding ONE actually at the end here. Sorry about this. It's E is the one that is changing, alkane, right? So ketone becomes propanone. So what are we changing here? From propane, so propane. So propane, we change that. You see, propane, there is propane, and we've got that side of the propane, and then where there's that E, you put the one, propanone, right? Then it continues from propanone. You have got what? Butanone. We have got what? Pentanone. We have got what? Hexanone. We have got what? Heptanone and octanone, and so on and so on. So this is the general naming of ketones, but it will always change whenever you are changing the functional group and all that stuff. So now guys, we're going to end this lesson here with part of the esters. We're going to leave it because esters is a combination of 2. For example, with the esters, the functional group, we say this is the functional group of an ester. Alright, so we have this part as the functional group of an ester here as actually this one. Now with the ester, example was methanoate. So it has got 2 parts, methyl, and the other part methanoate, which we need to actually look at them whenever we are looking at the topic called esterification. We'll look at that. It will make more sense when we name them. So guys, but for now we have to end the lesson, and in the next lesson I'm going to look at now the most, all of them are important, but this one is actually the most, is called IUPAC naming. And what does IUPAC stand for? International Union of Pure and Applied Chemistry Naming, which is the authority in the naming of all chemical compounds, especially when it comes to hydrocarbons. So IUPAC naming, these are international standards when that is used to name all the hydrocarbons. So we start now to give them proper names. When I was looking at the homologues series, this thing of propanone, octanone, these are generic names, but now we need to get the actual naming so that we follow this IUPAC naming. So I will encourage you guys, get hold of the next lesson. If you're not subscribed, I'm sorry, there's nothing I can do, but I will encourage you therefore to subscribe. If you want to watch this alone and you're not sharing, again I say it's a pity on you, because someone somewhere who is a friend to you, who is a loved one, also wants to benefit like you're benefiting. So why watch alone? Just share, because at the end of the day, remember, sharing is caring. This is the 24-minute lesson. We've come to the end of our lesson. Thank you.